Hello, I'm Fadzai Matambo. I'll be talking to you about the Zookeeper application, which we find in the Hadoop ecosystem. For a start, I would like to talk about the Hadoop ecosystem. The Hadoop ecosystem is a collection of various applications which are used to perform different duties or activities within the Hadoop ecosystem. And maybe for me to give you an overview, or maybe to just enlighten ourselves about the Hadoop system, we can explain it as the life in the jungle, where there are different animals which perform different activities, but they coexist within the same jungle. So in as much as they are different, they have ways which they live together. So we can take this jungle and fit it within the way data is collected in the present day. We find that we have a lot of data which is coming in. This data comes in different formats. Some of it is organized, some of it is not organized, some of it is videos, pictures. So this is like a jungle of data that we are receiving. And now for us to get value out of this spectrum of data, we have the Hadoop ecosystem, which encompasses a lot of applications which are used to create order from all these different types of data that we receive. From what we are seeing on the slide, you find that there's an Uzi application, there's a Scoop application, there's a Hive application. All these applications, they perform different activities. And at the same time, we also find the Zookeeper application, which is mainly used for coordination within the Hadoop ecosystem. So what is the Zookeeper? It is a distributed coordination service to manage large sets of hosts and enable synchronization across a cluster. So the Zookeeper coordinates all the other applications within the ecosystem. It solves this issue with its simple architecture and application interface. And the main goal is to make systems management easier with improved, more reliable propagation of changes. So we find that the Zookeeper ecosystem needs coordination so that each and every application performs its functions to its best ability. So the Zookeeper is the one which makes sure that that coordination is provided. So the common services of Zookeeper, they include naming, configuration, cluster management, leader election, locking and synchronization services, and data registry. So we find that with naming, it has to identify each and every nodes within the cluster. For configuration, we find that latest and up-to-date configuration information of the systems for a joining node. More nodes will be joining the system, and all of them, they need to be appropriately named and also to be allocated appropriate functions. And on leader election, we find that electing a node as a leader for coordination purposes actually assists within the system to make sure that communication is in order and it is done well. And we find that there is that synchronization where there's locking the data while modifying it. This mechanism helps in automatic failure recovery in case where there are issues of when the system goes down or when there are any challenges within the system. So the synchronization will make sure that data is locked and there isn't much of a modification when the updating is being done. So the benefits of the Zookeeper, we find that we have a handful of them, which includes synchronization, ordered messages, serialization, speed, order, scalability, the fastness of the Zookeeper, the reliability, the atomicity, and timeliness. So we find that the Zookeeper has got so much benefits to the Hadoop ecosystem. And These benefits are further explained in the next slide. So on synchronization, there is mutual exclusion and cooperation between server processes. This process helps in Apache HBase for configuration management. Serialization includes that it encodes the data according to specific rules, ensures your application runs consistently. And atomicity on data transfer, when data is transferred, it has to either succeed or fail completely. No transaction is partially done. So when it fails, it has to report that it has failed. When it has succeeded, it has to report likewise. So no work is half done. But maybe to mention, the major drawback of this Hadoop Zookeeper application is that if there is a failure within the Zookeeper application itself, there is a central failure and it can cause problems within the whole Hadoop ecosystem. And to move forward, I will talk about the architecture of the Zookeeper application. We find that there is a leader server which is selected from that election I talked about before, and there are follower servers. So these servers, the follower servers, they all communicate with the leader server, and the follower servers are the ones that communicate. All the servers actually they communicate with the clients. So you find that there is a continuous communication among all these elements within the Zookeeper. And to explain further on the elements within the Zookeeper architecture, we find that the client represents nodes in a distributed application cluster which access information from the server. The server is one of the nodes in our Zookeeper ensemble. It provides all the services to clients. It gives acknowledgement to clients to inform that the server is alive. The ensemble is a group of Zookeeper servers, which is either follower or a leader. The minimum number of nodes that is required to form an ensemble is 3. So that will make sure that we have a leader server and 2 follower servers. In case of any challenges on the follower servers, the other follower server will be there. So the follower server node, it follows instruction from the leader server. Then for the hierarchical namespace, we find that the Zookeeper node is referred to as Z node in short. Every Z node is identified by a name and separated by a sequence of path, which is a slash. The config namespace is used for centralized configuration management, and the worker namespace is used for naming. So configuration and naming, these are some of the duties which are done by the Zookeeper application. And the diagram there, it shows that from the top node, which is the Z node, they are configuration and worker nodes. So these are the ones which are now expanded going down. We have types of Z nodes. One is the persistent Z node, the ephemeral Z node, and the sequential Z node. The persistent Z node is alive even after the client which created that particular node is disconnected. By default, all Z nodes are persistent unless otherwise specified. And the ephemeral Z node are active until the client is active. Once the client goes down, the ephemeral Z node goes down as well. So for this reason, on the ephemeral Z nodes are not allowed to have a child further, because once the client goes down, all those things, all the children will be under it will also go down. So we don't have any children below a ephemeral Z node. If a femoral Z node is deleted, then the next suitable node will fill its position, and femoral Z nodes play an important role in leader election. Then we have the sequential Z node, which can either be persistent or femoral. When a new Z node is created as a sequential, then Zookeeper sets the parts of the Z node by attaching a 10-digit sequence number to the original name. So this is the identification feature of the Zookeeper application. It has to make sure that it can distinctly identify each and every node within its cluster. Then the workflow within the Zookeeper, we find that packets of work moves from the clients into the servers. So from there, you find that the servers will be communicating between the follower and the leader, and in there is data, there is request processing, there is broadcasting, there is database replication. So we find that all the data that is sent into the servers, it is replicated and it will be stored in different locations. And that makes it a point that whenever one node is down, the data within that node will have been replicated into another node. So there is not much of data loss. So the Zookeeper ensures that there is no data loss. Then the components of the workflow are explained here, where we have the write, the read, the replicated database, which is used to store data in the Zookeeper, and the leader and the follower servers, we talked about them before. And the request processor, it is present only in leader node. It governs write requests from the follower node. And then atomic broadcast, they are responsible for broadcasting the changes from the leader node to the follower node. Then the basics of the Zookeeper application interface. We find that an example is referred to as the Zookeeper client, or simply the client, and the Z node is the core component of the Zookeeper ensemble and Zookeeper API, and provides a small set of methods to manipulate all the details of Z node with Zookeeper ensemble. And the Zookeeper ensemble assigns the session ID for the client. It sends heartbeats to the server periodically. Otherwise, the Zookeeper ensemble expires the session ID and the client needs to reconnect. So you find that we have talked about this before, where there is need for identification, there is need for you to send the heartbeats to make sure that each and every node which is alive, it is active and is always sending messages to the leader. And we get that disconnection from the Zookeeper ensemble. Once all the tasks are completed, if the client is inactive for a prolonged time, then the Zookeeper ensemble will automatically disconnect. So if you don't send messages to the Zookeeper ensemble, then it will have to automatically disconnect that connection. So with all that, we find that the Zookeeper application was originally built at Yahoo, where they needed an application which provided them with data transparency, better performance, robustness, centralized configuration, and coordination. So with the features of the Zookeeper application, we find that it sits very well with the requirements which were needed at Yahoo then. So as an ending, I hope I have tried to explain what the Zookeeper application is and how it fits within the Hadoop ecosystem. So we find that all the coordination comes from the Zookeeper. I thank you.